Practice set 18, number 2. Determine the length of x as shown in the diagram. The triangle is isosceles. We're going to begin by drawing an altitude from the upper vertex between the two equal sides of this isosceles triangle to the opposite side. An altitude forms a right angle. It also bisects the side that it intersects. So if we have an entire side length of 7, that means from here to the point where the altitude intersects the side is half of that distance. 7 divided by 2 is 3.5, and likewise on this half it has a length of 3.5 inches as well. Now that we have an angle and a side, we have enough information in this right triangle, which is also equal to the right triangle on the other side, to solve for the missing length. So I'll rewrite just one of these equal right triangles with our acute angle. We'll use that as our reference, and we'll label the sides of this right triangle. Always starting with the longest side, the side opposite the right angle. We're looking for the hypotenuse in this triangle. With A, our reference through the triangle, the opposite side is actually our altitude that was drawn in the isosceles. And our third side is the adjacent side. Going to the TOA mnemonic to determine which one of the trigonometry formulas to use. We'll start with sine. It's the opposite over the hypotenuse. We don't know anything about that height or opposite side, nor are we looking for it. So sine is not a consideration. Cosine comes next. It's the ratio adjacent and hypotenuse. We know an adjacent length. We're looking for the hypotenuse. That will be the trig formula that we'll use. Cosine of the angle is equal to the adjacent side over the hypotenuse. Replacing the variables with the values that we know. The acute angle, our reference angle, has a measure of 20 degrees. The adjacent side is 3.5, and the hypotenuse is our unknown. To solve this equation, we want to get rid of the denominator, and so we'll multiply both sides by x to maintain equality. We'll leave the left-hand side as is for right now. On the right-hand side, this x has a denominator of 1. When multiplying fractions, when we have something common in the numerator and the denominator, they will cancel one another out, because x divided by x is 1. 3.5 times 1 divided by 1 is 3.5. To solve for our x, we need to undo the multiplication. The opposite of multiplying is dividing, so we will divide both sides by cosine of 20 degrees. Cosine of 20 degrees divided by cosine of 20 degrees leaves us with a 1. X times 1 is x. And now we're ready to use our calculator to determine the value of this fraction or division problem that's left. I have a traditional scientific calculator. To simplify this expression, we'll start with the numerator value, 3.5 divided by, and as I said, this is a traditional scientific calculator, so I next need to start by putting the angle measurement in and then striking the cosine key. What we see right now is not the length of x. We're seeing the ratio for the cosine of 20 degrees. We have to finish the division problem with an equal so that that is completed, leaving us with a length of 3.7 inches for the hypotenuse in this right triangle, and translates into this side of this isosceles triangle has a length of 3.7 inches.